Okay, so today we're working on a 2006 Toyota Corolla. It's got the 1.8 liter, and we're going to be testing fuel systems. So we have our injectors right here, and we have access to our fuel pump right here. All right, so I've pulled up the wiring diagram, and we have our 4 injectors right here. They are all ground side controlled by the ECM, and they're getting their power. If you follow this line, you'll see, come on, this does not want to slide. There we go. Right here, when you turn the ignition either to on or start, it receives the full power. All right, I just want to talk about this a little bit more. So we have, as I talked about, we have our battery voltage going to each injector right here. It's being spliced, and these all share the same power. Now, with this vehicle that we were working on, our Corolla was ground side controlled. So what that means is that right here we have the ECM, and what it's going to do is when it wants to actually power the injector or use it, right? Um, it's going to flip a switch in here, which is essentially going to take this wire, the blue one, or for other injectors, it's going to be this white one, black one, and then our yellow. So anyways, if it wanted to activate this injector, what it's going to do is it's going to flip the switch, ground it, and once this gets both battery voltage and is grounded, it will actually fire this injector. So with ours, our firing order was 1, 3, 4, 2, and it would just do that in that exact order. All right, so I'm just going to talk about our fuel pump real quick. It's also, again, very simple. So we have our circuits. So we got our ground right here, just goes straight to the fuel pump. And then we have 4, which is just getting battery voltage as well. All right, so we're about to perform a quick test. It's just a simple voltage drop test. So we're going to be going across pins 4 and 5 on the fuel pump, which is just our battery positive and negative. And you just want to make sure that it's receiving full battery voltage as it's intended to. All right, so we are currently back probed into our power and ground for the fuel pump. Right now we've got a reading of pretty much nothing. We'll call it 0 volts because it needs to be in the start position just so that the relays get activated. So go ahead and start the car. And we're getting battery voltage now, which is what you want to see. So we know that our fuel pump's also getting power, and obviously by the fact the car started, our fuel pump has power. All right, so the next test that we performed, we wanted to get a picoscope reading. So that blue wire you see is going to be connected to the ground side of the injector, which if you remember us talking, that's what is actually being, it's ground side controlled. So the switch in the ECM is going to close that connection and actually give that signal to actually fire the injector. If the block on the right, I'll get a closer up picture in a second, but that is a amp clamp, so that'll show you the amperage readings, and I'll show you how all that lines up. Okay, so here's a close-up of what we were actually doing. So this right here is our ground, and here's our power wire. Something that kind of gives that away is that here's another black and white wire. So that's going to be your common wire. And this big thing here is our amp clamp, so that's what's actually reading the amperage. You only want that on one wire because these are the same circuit, and it'll just screw up the readings. So I'm gonna need one wire to have that wrapped around, and then that back probed, and then this also needs to be on the battery positive as well. All right, so you can see our picoscope and all these wires going down, which I just explained what everything's purpose is. This is with the vehicle running, and you can see the amp clamp and where everything's connected. All right, so I'm going to talk about our waveform reading, which is what we got from the test that we just saw. Okay, so first off, let's start with the actual saturated switch waveform. right? So we have right here, this should be battery voltage all throughout there. That's with it off. And as you can see, there's an area. So right here and here, um, in between this, which is this right here, that's our actual on time of the injector, which is it actually spraying fuel into the cylinder. So here you can also see our amperage lines up with that, and I'll talk about that in a second. But right now, what's important is that we keep going on with this. So you'll follow this around. This should get close to ground, pretty much 0 volts during the on time. And then you can see that it's going to spike up in voltage. This is what you want to see because that voltage spike actually shows the magnetic field strength. And depending on your reading, you can see if it's within spec or not. Then it follows down here, and you see this little hump right here, and that hump actually indicates the mechanical movement of the actual injector, which is pretty cool. So when this magnetic field collapses, that voltage spike, and then you can read the height. Now, if we go into the amperage, which is why we had that amp clamp hooked up to get this reading, you can see that right here, it's all off time. And then right when it turns on, it slowly goes up in a slope. Now I say slowly loosely because this all happens within milliseconds, but it will go up in a ramp and then drop off when it is off. So what you're looking for in this reading is you actually want to see that it's going up like this. So if you were to see a sudden spike, that's not what you want to see, because it's going to indicate that your injector may have a bad winding.